Hello everyone. I'm super excited to show you a quick demo of this agentic SOC Analyst AI that I've developed in this past couple of few weeks. And the tech stack that I've used is based on Python, OpenAI, Microsoft Defender for Endpoint, and Azure Sentinel Log Analytics Workspace. So let's dive right into it. Now, as you can see on my screen, it shows agentic SOC Analyst at your service. What would you like to do? Now, the way this AI models work is they accept two basic prompts. One is the system prompt, and another one is the user prompt. Now, the system prompt is hidden behind the layers. We, as users, they don't see it usually. And the main uh, thing about system prompt is that they define the role and behavior that the model, the assistant that we are using, it will adopt based on the user query context. So if we ask him to be a tier 1 SOC analyst, it will be an analyst and it will analyze it accordingly. If we ask him to write some poems, then it will act like a poet. I hope you get what I'm talking about. So the user, I have already defined the system prompt for our use case to be a tier 1 SOC analyst agent, and also the parameters and everything I have defined so that it acts accordingly and it prevents from hallucinations and all those errors. Let's write and investigate this particular workstation for any malicious or suspicious command line executions in past 3 hours. Now it's deciding log search parameters based on user request. So the way it maps our natural language user query into the particular metadata that we require in order to fetch the logs from KQL is through something known as tools. Now we can think of this tools object as form that we need to fill out. Now the model will fill out the form for us based on specific instructions in the form of system prompt and user prompt that we are giving. A user prompt was this particular thing, and system prompt is not the system prompt that we are giving for threat hunters. It's another prompt that we have defined specifically to fetch this metadata for us. And in that prompt, we have defined all the tables that this agent can look up into in this tools object, and it will see the user prompt, and it will map the time and all this to a relevant table, to relevant time, fields, device, and it will give a rationale that why it has chosen this particular table out of the other tables that we have provided. Now, after sending us this metadata, the next step is to validate that actually the fields and tables that it has generated, it actually matches the ones that are there in the log analytics workspace, right? So we do this with the help of something known as guardrails. Now, you can think of guardrail as the fences or the rules which will prevent the AI from getting rogue, from hallucinating, from giving wrong outputs, in short. Now, after the fields and tables have been validated, we are constructing the KQL query, which we will use to fetch the logs. So it's a very basic query device process events where device name starts with this particular workstation name and it's projecting these fields. Now, important question arises is why are we using this exact query, and why not we are searching for other devices, or why not all the fields which are present in device process events. Now, device process events has more than 30 fields if you see in Sentinel. Now, if we fetch all the fields and all the data in it, the amount of input will rise exponentially and the cost associated will also rise. So in order to optimize the cost, to optimize the resources, and to optimize the time, we have narrowed it down to exactly what we require. So it has fetched 269 records from this particular workspace ID by using the Sentinel log analytics API. And after that, we are building threat hunt prompt instructions. Now in this, we are giving 4 things as input to the API call. First is the system prompt, which I talked about at the start. It will act as SOC analyst and it will behave accordingly. Next is the user prompt. Third is the logs that have been generated, 269 records. And fourth is the formatting instructions, the way we want our report to look like. It will combine everything and will calculate the tokens generated. Now tokens, yes. OpenAI, the way it works is it breaks down our input into various tokens, and these tokens it processes and it gives the output. Now there is a limit based on the model that you can select in OpenAI. Now there are various models available. I've just selected these 4 for as a proof of concept in this demonstration. And for each model, you can see there's an input limit on the number of tokens that can be inputted, and also the rate limit that tokens you can send per minute to the model. So green is like we are in the safe range, so we can choose any of the 4 models. Right now we have selected ChatGPT 5 mini as default, and we can see the estimated cost for this particular API call would be 0.007 cents. If you are selecting GPT-5, it will be 4 cents. So let's give it a try. We will select GPT-5. It's executing the threat hunt. So now we are sending the API call to the ChatGPT-5 model with our queries. Okay, so our threat hunt has been completed. It took around 1.5 minutes for it to complete, and it has found 3 potential threats. Let us look at the results. As you can see, it has successfully detected obfuscated PowerShell execution, which is launched via batch file. Confidence level is high. That means it has flagged as at high severity. And you can read the description over here. The suspicious thing is happening. The MITRE attack, it has successfully, and there is a log evidence, recommendations, and indicators of compromise. Similarly, for thread 2, this is for credential dumping. It has detected. Now this is to note that it's one attack that was run by me. I have just mimicked a basic malware demonstration in which we have used obfuscated PowerShell execution. Then it's looking for credentials through credential dumping. Then discovery commands through who am I, system info, net user. As you can see, this all has been logged. Now the next stage, once a high severity threat has been found, the next step is to prompt the user that would you like to isolate the VM for the containment phase. Now, if he selects yes, the device will the AI will send a request to the Defender for Endpoint using Graph API, and based on the workstation ID, and it will isolate the device for further investigation. So let me show you. This is the device on Defender for Endpoint. Yeah, the risk level is high because I've already executed this partial. It has flagged it as an incident. That's why it's showing high. But no worries. As you can see, it's asking for us to isolate the device. Over here, this is our device. So let's do it through our agent. I'll say yes. And as expected, the VM has been successfully isolated. We can verify it. Let me refresh. And you can see it's now showing release from isolation. So our device has been successfully isolated. We can do all the kinds of investigation we want, and we can release it later on. Now, the moment a high alert was detected, the I have created a logic for post-incident activity in order to pivot to other systems in order to detect whether this similar pattern has been found in other systems or not, or in future if the similar kind of pattern was detected in the organization, then there should be a alert rule which we can create. Now, to save the analyst's time, automatically this rule will be created by AI only if the severity is high. This saves uh, for low priority or medium priority. We're not creating alerts because most of the times it's false positive. And as usual, I'm creating the estimation for the cost based on different models. So we'll go with ChatGPT 5 this time. And now it's it send the API call to the model GPT-5 to create a KQL query based on system prompt. Now this system prompt would be different from the one we used during threat hunting. So this is another system prompt I have used that will take the threat hunt reports as the user query, and it will act as a threat detection engineer in order to create a KQL query based on certain rules, based on the rules that KQL has, in order to avoid hallucinations. As expected, this is the Sentinel rule created. Now, before this, it's also validating that whether the KQL generated has it's safe to use. It doesn't has any drop or delete commands or anything harmful that may affect our Sentinel workspace. And also, it's validating the schema structure, that the table fields should be appropriate. And this is the name of the Sentinel rule that was created, and this is the query. Now, again, human should be there in the loop in order to verify and validate the KQL query. Uh, it should be appropriate. It should be based on a particular signature pattern to minimize the false positives. And it's also logging in the MITRE info over here. So it asks, do you want to deploy this tool to Microsoft Sentinel? I'll select yes. Success, it's sending, and it has deployed to Sentinel. Rule ID is this. Now we can verify this. So let's go to Microsoft Sentinel Analytics. Let's refresh it. So you can see rule ID D09, D09 2EA, to EA. This is the exact rule that was created. It detects partial executed with this. It's AI generated. High severity. This is the exact KQL command which was generated. It will run every 1 hour and it will trigger if query returns more than 0 results. And right now it's enabled. So yeah, this was a short demonstration of the project. Now one more feature I have added in it, and that's the antivirus scan, but it will only work if the severity is not high but it's medium level. So you can scan for any malware or anything automatically, and it will generate a report and give it to you. So yeah, this was all from my side. Thank you for watching and see you next time.